Okay, today in honors chemistry, let's talk about binary ionic compounds involving transition metals and then those under the stair step. So we're talking about metals that can have more than one charge. Let's go back and real quick, binary means that the compound will just have two things in it. Ionic means that it's between a metal and non-metal. Okay, now remember we said yesterday or yesterday's lesson that zinc and cadmium always have a 2+, silver always has a 1+, and then aluminum is a 3+. So what we talk about today, even though they're under the stair step and in the transition metal section, they are not included. Okay, so most transition elements can form two or more positively charged ions. So elements, metals, will always give up electrons, okay? They're never going to gain electrons. When naming a compound that contains a transition element, the charge of the transition element is indicated by a Roman numeral placed after a Roman numeral placed in parentheses after the transition metal name. The exception once again is silver, zinc, and cadmium have only one possible charge, so we do not give them a Roman numeral. So for instance, if we were talking about the iron 2 ion, when you name it, you would say iron Roman numeral 2 in parentheses. If it were the iron 3 ion, you would call it iron Roman numeral 3 in parentheses. So the Roman numeral indicates the charge on the metal. Okay, so write the formula and give the name for the compound formed between Cr3+ and F-. Okay, so Cr has a 3+, F has a 1-. Okay, so when you write the formula, you remember you crisscross to balance your charges, so it turns out to be CrF3. To name it, we know chromium is a Roman numeral 3 because it has a 3+ charge, so you would name that chromium, Roman numeral 3 in parentheses, fluoride. So once again, in ionic compounds, you will name the non-metal ending in "ide." Okay, so for Cu2+ and bromine, so we've determined copper is a 2+. So you would write the formula for this as CuBr2 because this was a 2+, this was a 1-. They didn't equal 0, so you crisscrossed. So it's CuBr2. You would name that copper, Roman numeral 2, bromide. Okay. Iron with a 2+ and oxygen. Well, iron we said it's a 2+, so Fe2+. Oxygen is a 2-. They equal 0, so we don't have to crisscross. So your formula is going to be FeO, and you would name that iron Roman numeral 2 oxide because we know iron's charge is a 2. Okay, so put the video on pause and then practice naming the following. And if I give you the formula to determine what the charge is on the metal, look at the non-metal first to determine the charge of what the metal would be. Okay. Okay, so this first one, so we're going to look at, we know copper is going to have more than one charge, so we're going to look at oxygen. Oxygen is a 2-. We only have one oxygen, so always look to see if you have a subscript. So if this side is 2-, then this side has to be a 2+. We only have one copper, so it is a 2, so you would name this copper, Roman numeral 2 in parentheses, oxide. Okay, going across. So once again, we know that copper's got more than one charge, so we're going to look at sulfur. Sulfur is a 2-. So remember, it's in 6A. This family always has a 2- charge. So until you get used to it, if you want to go through and put 1+, 2+ above 2A, 3+ above 3A, and then 5A is 3- because they're going to pick up 3. 6A is 2-. They pick up 2 electrons if you put them with the metal. 7A is a 1-. So if this side is a 2-, this side has to be a 2+. You have 2 coppers. So each copper has to be a 1 because if you put a +1 here, 2 times a +1 gives you a 2+. So this would be named copper, Roman numeral 1 in parentheses, sulfide. okay? Okay, COF3, so cobalt is going to have more than one charge, and so you're going to look at fluorine. Fluorine's a -1, so you say 3 times -1 is a 3 minus. So if this side is a 3 minus, then this side has to be a 3 plus. So you would name this guy cobalt, Roman numeral 3, fluoride. That's a 3 in there. Silver. Silver, remember, is always a +1, so you're not going to give it a Roman numeral. So you correctly would name this silver chloride. Okay. 10 has more than has 2 possible charges, and so we're going to look at iodine. Iodine's a -1, but we have 4 iodines, so that makes this a 4 minus. So if this is a 4 minus, this side has to be a 4 plus. So you would name this 10 Roman numeral 4 IV in parentheses iodide. Okay. And then FeS, iron is a transition metal, so it lies in the this area in here. So anybody down in this area normally has a more than one charge. So we're going to look at sulfur, S2 minus. There's only one sulfur, so this side has to be a 2 plus. You only have one iron, so it has to be a 2. So you would name this iron Roman numeral 2 sulfide. Okay. Now, before we go to the next section, let's do this real quick. On your table, let's write in the probable charges for some elements. So we have chromium. Chromium is normally a 2 plus or a 3 plus. The same for manganese. The same for iron. The same for cobalt. And the same for nickel. Okay. Copper is a 1 plus, 2 plus. Zinc, we already said, is always a 2 plus. Cadmium is a 2 plus. Silver is a plus. And so if you'll look, chromium all the way through nickel, they're in a group, so it helps you kind of, if you'll categorize things like that, it might make this easier. And then tin and lead are both in 4A, so they're normally a 2 plus, 4 plus. 2 plus, 4 plus, okay? So if you'll remember this, it's going to make this next thing we talk about a little bit easier. An alternate way to name transition metals is to use their Latin name. The lower oxidation state or lower charge will end, when you name it, you will end the name in us, and the higher oxidation state will end in ic. So for instance, FeO, so we know Fe's charge is a 2 plus here because of oxygen. So this is the lower oxidation state for iron, because iron can have a 2 or 3, so you would name that ferrous oxide, because iron's Latin name is ferrous. And then Fe2O3, well, oxygen's a -2, so 3 times -2 is a 6 minus, so this side is a 6 plus. You have 2 irons, so they're each a 3, so that means iron in this instance is the higher oxidation state, so the higher one ends in ic, so you would name that ferric oxide, okay? All right, so now that should give you enough information that you can do set 2, ionic compounds with variable charges. Thank you.